Hey, what's up everyone? I hope you guys are doing absolutely fine. First of all, welcome back to my YouTube channel, and today we'll be looking into the event loop like never before. So, um, I am expecting that you guys might have heard about event loop, like anyone who is learning JavaScript, who is learning Node.js, and definitely event loop is something which you have came across. And you guys might have also seen a couple of videos or a couple of tutorials or anything on event loop, and the one thing which we have always heard of is phases and macrotask and microtask queue. So tell me honestly, how many different phases and how many different queues have you heard of? Macrotask queue, microtask queue. But what do you think? There are only two queues in event loop, and is this totally correct? Well, let me tell you one thing. This is the half truth. So when anyone says you that event loop has only two, event loop has macrotask queue and microtask queue, that is the half truth, and this is true only in certain scenario. That is when you are on a browser. Let's decode carefully. Event loop actually came from Node.js, to be honest. Event loop has different phases. Correct. Event loop has timers. Event loop has IO callbacks. This is the basic event loop. If you can see on my screen, there is this timers phase which has set timeout, set interval. There is this IO callback phase, system input outputs. There is this idle prepare phase, which is like an internal phase which we are not talking about, because this is something which we are not concerned about, and this is also something which we are not concerned about. The main three phases are the timers phase, the poll phase, and the check phase. Poll phase is mostly for file input output, like when you're reading a file asynchronously using the fs module fs.read file with the name of the file, and you specify a callback, right? That's the usual scenario. This is the name of the callback which gets fired when the file reading has been completed. And this particular callback for this file reading operation, that callback is registered in the poll phase, and check phase is for the setImmediate functions. So what do you think? Are there only two queues in the event loop, macro and microtask queue? Microtask queue, we all know microtask queue is for promises, correct? Which is this one. The microtask queue is for promises, highest priority, correct? But let's understand carefully. If we think that event loop just has two queues, macro and microtask queue, then this timers, the callbacks of the timers, callbacks of the poll phase, and callbacks of the check phase all should go into one macrotask queue, correct? But I also know one thing, that a queue is a FIFO data structure, first in first out. So in queue, whatever is at the first position will be taken out first. So if I'm queuing timers callback, poll callback, and check phase callback in the macrotask queue, then how am I deciding, like, when my execution, when my compiler is when my event loop is in the timers phase, which I'm saying, I say that I will pick the timers callback, and if the file reading operation has been completed, then this callback has to be triggered. That means the event loop will automatically move to the poll phase. But what if there is a callback already registered for setImmediate? Because it's a queue, right? I understand that in queue data will be pushed like callback 1, callback 2, callback 3, and so on. This is the first element, and this will be picked first, then this will be picked second, then this will be picked third. Compiler can't choose between this callbacks. Okay, I want to pick this callback, I will pick this callback first, then I will pick this callback first. Like, this is callback of timers, this is the callback of setImmediate, this is the callback of the file input output operation, and I'm processing this callback, and suddenly file reading operation is completed. This callback has to be triggered. I skip this callback, I pull this callback. Is this even possible? No, this is not possible. This is a FIFO data structure. it will always execute in first in first out. Whatever is the first will be executed first, no matter what. So in the Node.js, it is not possible to just have one macro task queue, correct? So what happens is, every phase, like timers phase, IO callback phase, idle prepare phase, poll phase, check phase, close callback phase, every phase has its own queue. That means, let me just simplify this. If this is the timers phase, then timers phase will have its own queue. This will be timers queue. Callback 1 of timer, callback 2 of timer, callback 3 of timer. Then we have, let's skip the IO callbacks. Let's skip the IO callbacks and the idle prepare phase. We are not concerned about it. Let's check the poll phase. When the event loop is in the poll phase, we have a poll queue. This is the callback 1 of the poll phase, callback 2. Now this callbacks are specifically callbacks of the file input output operation. That means whatever this operation is there, fs.read file, sorry for the background noise. So whatever this file operation is there, fs.read file, and whatever file we are reading, the callback of this callback is queued in the poll queue, inside the poll phase, not the poll phase, but it is in the poll queue. Similarly, we have check phase. Similarly, we have the check phase. Callback 1 of check phase, callback 2 of check phase, callback 3 of check phase, etc, etc, etc. And we have a microtask queue. Now this microtask queue doesn't belong to any phase. Callback 1, callback 2, callback 3. This microtask queue doesn't belong to any phase. This is a system level global queue. What is queued inside a microtask queue? Promises. There is a promise. Promise dot, whatever promise you are doing, promise dot resolve dot then, whatever promise you are throwing, or you are making a new promise, you are creating a new promise. You're saying resolve, reject, doing some operations, and you're saying resolve, and you're catching this promise using dot then. Can you think about what is going to go in the microtask queue? Is this going to go into microtask queue, or is this going to go into microtask queue? Can you think of this? We'll come to this later on, but this is something which you should think about. Okay, so what is this? Okay, so we have several different phases. We have the timers phase, we have the poll phase, check phase, microtask queue, etc, etc, etc. So what happens is, when the call stack is empty, when the call stack becomes empty and there is no other functions or no other statements to get executed in the call stack, the execution is transferred to the event loop, and event loop starts from the top, from the timers phase, and it comes down, exhausting each queue in each phase. That means when the event loop is in the timers phase, it will execute the entire timers queue before moving into the next phase. Before moving into the poll phase, it will exhaust the entire timers queue. It will execute every callback that is present in the timers queue before going to the poll phase. Similarly, when the event loop comes into poll phase, it will completely exhaust the poll queue before moving to the next phase. And similarly, things go on. But what about the microtask queue? So microtask queue, as we know, is the highest priority queue. What does that mean? That means that if my event loop is in the timers phase or pool phase or check phase and my event loop is executing one of the callback, ideally what happens is that this callback is picked, it is taken to the call stack, and in the call stack this callback is placed and it is executed. Once the callback is executed in the call stack becomes empty, execution is transferred again to the event loop, and now before my event loop was in the timers phase, right? Now this will go out of the event loop, this will go out of the timers queue since it's a FIFO, first in first out, the first will be removed, and now I should be executing the callback too. But before executing the next callback in that particular phase, my event loop will always go to microtask queue and check if there is anything present in the microtask queue. If there is anything present in the microtask queue, my event loop is gonna first execute that stuff. My event loop is gonna first of all exhaust the entire microtask queue before moving into the next callback. It will pick this, and that makes sense, right? Because it will pick this callback, place it in the call stack, execute this callback in the call stack becomes empty, execution transfers to the event loop before checking the next callback. Event loop knows that it is in the timers queue, it has to pick the callback too, but it will again check the microtask queue. Is there anything? Yes, there is callback too. Place it in the call stack, execute it, come back to the event loop, check the microtask queue first. Unless and until the microtask queue is empty, it is not going to execute another callback. And this statement is true for all the phases. Now I am in the timers phase. That's why I'm considering the timers queue and the callback of the timers queue. But the event loop can be in the poll phase. The event loop can be in the check phase. Doesn't matter. It will first complete the execution of its callback, return back to the event loop, and first it will check the microtask queue before executing the next callback in whichever phase it was. That is the whole concept of event loop, and trust me, this is where most of the senior developers, I'm not even talking about junior developers, this is where most of the senior developers fail, because this is the trickiest part. Now it might seem theoretically very easy to understand, before checking in, first exhaust the microtask queue before moving to the next callback in that particular phase, and this and that. But trust me, if I place a sample code over here, and if we start debugging it, this will become more tricky, and kind of it will be also a nightmare. Now we just considered all these queues and microtask queue, but there is one more system special queue. Now this is not a microtask queue, it's a system special queue which holds the callbacks of process.nextTick. This is a system special queue, and this holds the callback of process.nextTick. Now remember what I said earlier, that if my event loop is in any of this phase, and if my event loop is executing the callback, for example callback 1, if my event loop is executing this callback 1 will be placed in the call stack, it will get executed, call stack will become empty, execution will be transferred to the event loop will first check the microtask queue, correct? Now let me add one more thing. Even before the microtask queue, event loop is going to check the system special queue, which is the queue for process.nextTick. What is nextTick over here? nextTick is basically, over here, nextTick considers the next execution of the event loop cycle. Now when my event loop is, if my event loop is in the timers phase, and if my event loop picks this callback 2, what will happen? Event loop will pick this callback, take to the call stack, place this callback in call stack will get executed. After the call stack this callback will get executed in the call stack. Once there are no other statements in this callback, in this particular callback, that callback will be removed, or that whatever context that was created for this callback, that context will be removed from the call stack will become empty. The execution will be transferred back to the event loop. This is the next tick. This is called as the next tick. When the execution or the control which gets transferred from the call stack back to the event loop, that is called as the next tick. And before the next tick, you have to execute the system special queue. Even before the microtask queue, you have to execute the system special queue. This will be executed first. And how this will be executed? Callback 1 will be taken from here. It will be placed in the call stack. Call stack will get executed. Callback will be removed from the call stack. Execution will be transferred back to the event loop. Next tick, it will check first system special queue. If this queue is empty, it will check the microtask queue. Now it may also happen that promises, like new promise, like this promises may have your process.nextTick. That means what will happen is that this promise, which is in the microtask queue, it has registered a process.nextTick over here. So what will happen is that once this callback is executed and the event loop is going back, and the execution is going back to the event loop, first this special queue will be checked, and promise.nextTick is already registered. That will be picked first before even coming to timers queue or any of the queue. I hope you guys have understood the logic. And don't worry, this will be more clear once we look into some of the examples. But overall, I guess you have understood the logic over here. So what I'm gonna do is I'm gonna remove everything from here, and I'm gonna remove everything from here, and I am going to come over here, and let's try executing this sample problem. Okay, synchronous code first and then asynchronous code. No executing asynchronous code before synchronous code. Let's first of all, whenever a problem statement is given to you, you have to first identify the synchronous parts of the code. Console log S in console log E. Console.log, setTimeout is asynchronous, setImmediate is asynchronous, promise is asynchronous, process.nextTick is asynchronous. Plain simple. First, let's print it down over here. Let's print it down. First, S will be printed because this is the synchronous block. This everything is asynchronous. You don't have to think so much. This is synchronous. E will be printed over here. Sorry, E will be printed over here. Next what? There is a timeout with timeout of 0 milliseconds. Timeout will definitely go into the timer's phase. There is a setImmediate. setImmediate will definitely go into the check phase. Correct? And we have process promise.resolve, and this promise is immediately getting resolved. You see, promise.resolve immediately getting resolved. Then this callback will be registered into the microtask queue. Okay, that's fine. And what happens is that, so my execution, my compiler will check line by line. It will come over here. It will say this is synchronous block of code, execute it. So S will be printed. My compiler will come over here. It will see set timeout. Oh, asynchronous block of code. So what my compiler will do is, my compiler is not going to execute this callback. It will say, okay, set timeout. Okay, this should go into the timers queue. This will be, the callback will be thrown in the timers queue. setImmediate, the callback is again thrown into the check phase, into the check queue, not check phase, into the check queue. Promise.resolve then immediately resolving promise. My compiler will just take this callback and it will just throw it into the microtask queue. Process.nextTick and a callback over here in the process.nextTick. What my compiler will do is, compiler will pick this callback and it will throw this callback in the system special queue. And then compiler will come over here. It will see, okay, synchronous block of code. We should wait and execute. It will execute. E will be printed. Now, is there anything else in the call stack to get executed? No, the entire function has been completed. Call stack becomes empty, function context has been removed from the call stack, and my execution will go into the event loop. This is the first tick. When my execution, when my control gets transferred from the call stack to the event loop, that is called as the next tick. And when there is a next tick, which queue will be executed? Definitely the system special queue. So NT will get executed first. Let's print NT. Then what? Microtask queue P. Okay. Then what? Then timeout or setImmediate. Then timeout will get executed and setImmediate will get executed. But timeout and setImmediate is not simple. Timeout and setImmediate has again promise and next tick. Okay, let's decode this one by one. This is the callback which is stored in the setTimeout. When this call, what happens is that when my event loop goes into the timers phase, it will pick this callback, place this callback in the call stack, and call stack will execute and this is a function which is placed in the call stack. Call stack will execute this function line by line. Synchronous block of code, T will be printed. Correct? Promise.nextTick, this will be thrown again into the special queue, and this will be thrown in the microtask queue. Fine. Next, this will be thrown into the special queue, and this will be thrown into the microtask queue. Fine. No other statements to execute. Function gets removed from the call stack. Execution transfers back to the event loop. Event loop says, okay, next tick, because my execution is getting transferred from call stack to the event loop. This is the next tick. And since this is the next tick, what we'll do is we will execute the special queue first. That means this will be T-NT. Then we have promises. Obviously, after the special queue, we have to go to the microtask queue. So T-P. And once this is done, this obviously this will be executed in the call stack, and once this is executed, call stack becomes empty, transfers returns back to the event loop. Event loop checks the special queue, there is nothing in the special queue queued. Event loop checks the microtask queue, there is nothing queued in the microtask queue. Event loop goes into the check phase, and it will print I. And definitely after I, it will print I-NT, and this will print I-P. So but there is one ambiguity, or there's one ambiguity over here. There's one problem, that is deciding which one to get executed first, timeout or setImmediate. Now, as per the event loop phase cycle which we saw, or event loop phases which we saw, the first is the timers phase, right? But does that mean that the timers phase is always gonna get executed first? That's not complete true. I will tell you why. Because there is this poll phase also. Like, suppose if I'm doing a file reading operation, and if the file reading operation is done, then immediately event loop will be pulled into the poll phase, because poll phase is before the check phase, before the setImmediate callbacks are queued. Before the check phase, there is this poll phase. Poll phase is specifically only for callbacks of file read operation, like input output operation, file reading, file writing, file operations. If file reading has been done, the callback should be executed. Event loop is directly pulled into the poll phase, and poll phase, what happens is that event loop will pick a callback from the poll phase, executed. Now tell me in which phase the event loop is. The event loop is in the poll phase now. So which phase the event loop will go next if there are no other callbacks in the poll queue? Which phase the event loop will go next? The event loop will go next into the setImmediate phase, or the check phase. So in this case, not in this case, but it may happen that if the event loop is in the poll phase, then setImmediate will get executed first and then setTimeout. But if the event loop is at the beginning, and if there is no file operations over here, and if the event loop is at the beginning, that is in the timers phase, then timeout will get executed first and then setImmediate. But it all depends upon where the event loop is right now. If the event loop is in the poll phase and event loop is checking the poll queue, then the next setImmediate will be executed, even if setTimeout queue has already some callbacks. So that is also one thing. Let's execute this. So we have SENT, PT, TNT, TP, INT, IP. Now let's see if the order of this thing from T to IP changes or not, because there might be an ambiguity, like event loop might be in the poll phase, so instead of T I should get printed and then T. So maybe let's see. Oh, you see over here, after P I got printed I, and then INT, then IP, then T. That means at this point the event loop was in the poll phase, and then it moved into the setImmediate queue, and it executed the callback inside the setImmediate queue. So that's why I got printed first and not T, contrary to what we thought of. So this is one of the ambiguity, like it depends upon where your event loop exactly is right now. You know, that also matters a lot. We'll take one more we'll take a look at one more example, this one. So first thing first, we'll check the synchronous block of code. Let me just remove this synchronous block of code, A, obviously. Then setTimeout, event loop will take the callback of setTimeout and throw this into the into timers phase. Fine. setImmediate, not event loop, sorry, the compiler. Compiler will come over here, it will check setTimeout, asynchronous operation, take the callback, throw into the timers phase. Fine. setImmediate, take the callback, throw into the check phase. Fine. New promise, take the callback and throw into what? Macrotask? But wait a second. New promise, what will be thrown into the macrotask queue? This or this? See, whenever you are seeing new promise, that moment, this is not an asynchronous block of code. This is a synchronous block of code. When you are saying resolve, when you are resolving that promise, then, and you're catching that in the then block, this is what you're catching in the then block. That means whatever your promise is, I don't know when is my resolve gonna get called. So this is gonna go into the microtask queue and not this. Understand? This is gonna go into the this is gonna go into the microtask queue. So after A, ideally not I but G should get printed, because this is a synchronous block of code. There is no asynchronous behavior over here. Asynchronous behavior is when you resolve that promise. So after A, I will say it is G, then it is I. That's fine. Synchronous block of code. Then after this, my call stack has been emptied. I will go to the event loop, and mind you, this is resolving immediately. Okay, since this is resolving immediately, this callback will be immediately put into the microtask queue. So once my call stack is empty after I, and my execution is returning to event loop, I will first check the microtask queue. I will find H in the microtask queue. So I will print H in the microtask queue. Okay, so this promise is done. Let's remove this. Then my event loop is gonna go either into timeout or immediate, depending upon where my event loop is as of now. I'm assuming it goes into timeout. So obviously this will be pulled into the call stack. This is a synchronous block of code. B will be printed. As we discussed, this is a synchronous block of code. C will be printed. Then this goes into the microtask queue, and this gets into the check phase. but make sure this is already there in the check phase, this setImmediate. Now this goes into the microtask queue. Okay, and this goes into the check phase, thrown into the check phase after F. F is first in the check phase. Then E is there in the check phase. This is thrown into the microtask queue. This is thrown into the check phase. No other statements. Call stack emptied. Execution returns from call stack to event loop. First check the microtask queue. D. Okay, print D. Is there anything else in the microtask queue? Nothing. Then go to setImmediate. Print F first. Then print E next. Let's see what is the output. AGIH, BC and FB, YFP. Because what this is considering that setImmediate got executed first. So if setImmediate got executed first, and supposing that event loop is in the poll phase, setImmediate will get executed first and F will be executed first, then it will go to B. But what I said that I'm considering my event loop is beginning from the timers phase. Let me refresh this. You see B, now it came B. So A, G, I, H, B, B, C, C, D, D, F, F, E, E. Plain and simple. Let's try with, oh, this one. This is a good one. Let's try with this one. Pause the video for some time and just think about what will be the output for this. So synchronous block of statements first. Okay, async function read. Okay, console.log 4 synchronous block of code, print 4. That's fine. Set timeout. This will be thrown into the timers phase. Then read function call. But read function is a asynchronous function, so this will go where? This entire function will go into what? Microtask queue. Now, even though the function is declared as async function, this statement is synchronous. I will tell you when this function becomes asynchronous. This statement is synchronous. This will be executed synchronously after 4.1. Doesn't matter if the function is async or not. This will be executed synchronously. Problem happens when I do await, and when I'm doing await on any of the resource, I'm telling the compiler to wait. That means I'm telling the compiler to wait and schedule everything or just queue everything after await, into the microtask queue. Now, this does not go into microtask queue, this goes into microtask queue, but an execution context is created. Let's make it simple. Let's forget execution context and everything. Just assume that after await everything will go into microtask queue. Just assume this thing. So one will be printed, then await, okay, stop, go into microtask queue, everything go into microtask queue. Then what happens is that execution is controlled, execution is returned back to call stack. Over here I see, okay, I was over here in the read function, I come over here, this gets thrown into the microtask queue, but first this is there in the microtask queue, and now this will go into microtask queue 6. Okay, and then 7 will be printed. 7. Okay, go back. Okay, call stack empty, go back to the event loop, go back to the microtask queue first, resolve the promise. After promise is resolved, the execution context is awoken again, and this will be printed 2. After await everything will get printed 2. Then there is a file read operation. Okay, there is a file read operation. Now the callback of this will go into the poll phase, but the callback will be executed only once the file reading operation has been completed, not before that. So this is an asynchronous thing. Okay, this is an asynchronous thing. So and there is nothing else to execute. So my execution will return from the call stack. It will go to the again it will first check the microtask queue. It will find that in the microtask queue there is the 6, so it will print 6 over here. After printing 6, there is a there is a callback in the timers phase. Okay, but now what if the file reading operation has been completed? If the file reading operation has been completed, this poll phase will be triggered and this callback has to be executed. So either 3 will be printed first and then it will go to timers phase and 5 will be printed, or if the file reading operation has not been completed, it will go to timers phase, execute 5, and then it will execute 3. Just depends, you know. If I run this code, I'll get 417265. You know, I'm assuming that the file reading operation is completed, so poll phase will be triggered, and this poll poll phase will be triggered, and the callback in the poll queue will be executed, that is 3 got executed, and then timers. But we generally don't know when. You see, now in this case 417265. So file reading operation was not completed, and hence my event loop went into the timers phase, executed the callback which was there in the timers queue, and then file reading operation got completed, and then it printed 3. So these problems are kind of simple, not that tough. Just remember a few things. New promise, if it is a new promise, when you do a .then, when you resolve that promise, then the callback, you know, wherever you are catching that promise using .then or .catch, that is going to go into microtask queue, not the statements inside new promise. You know, that's just a promise declaration. Async function, asynchronous function do not directly go the entire function do not go into the microtask queue. Only when you're awaiting inside that function for any of the resources, then that particular thing goes into microtask queue. Okay, an execution context is created, and once that particular resource returns some output, okay, the result of that goes into microtask queue, and once that particular result gets executed, the execution context triggers, and everything after that particular await starts executing back. Okay, that happened over here, you know. When I awaited on this resource, though it is resolving immediately, but since there is an await, my compiler will stop and it will just move ahead. It will not check whether this is immediately resolving or not. What happens is that since this is immediately resolving, this will be immediately queued into the microtask queue. But suppose if this was a fetch operation, maybe suppose operation, and then I'm saying .then if I'm doing a fetch operation, suppose, okay, if I'm doing a fetch operation, there will be some output const x is equals to await fetch. There will be some operation. What happens is that this, when I'm waiting over here, my JavaScript or my Node.js compiler, it will basically wait for this resource to be completed. Once this resource is completed, it will just trigger the execution back. But this thing is gonna go into microtask queue. Okay, and yeah, pretty much that's it. You know, these are the simple things you should be remembering about event loop. Yeah, and another thing, we saw that there are several different phases in event loop. Like, let's go back. Okay, so we saw that there are several different phases in the event loop, but this is in the Node.js environment and not the browser environment. But when we are on the browser, that is the moment when there is just one macrotask queue and one microtask queue. In the browser environment, there is no process.nextTick. There is just promises which goes into microtask queue. And in the browser environment, there is no check phase. There is no setImmediate on the browser. Like if you come over here and if you just do immediate, there is no setImmediate over here. There is no setImmediate on in the browser. So there is no check phase. There is no socket connection on the browser, so there is no close callback phase. There are no file input output operations on the browser. This is only in the Node.js environment, so there is no pool phase. Idle prepare, just forget this. There is no IO callbacks, system IO callbacks, because it's a browser environment, cannot talk with the internal system, so there is no this. There is just timers. There are just timers. So it makes sense to just have a one queue, macro task queue, in the browser environment. But if you are talking about the Node.js environment, there is no one queue. There are multiple queues, as we discussed now, and based on which phase the event loop is, it decides which queue to execute. The rule of thumb you should always remember is that the callback which is in the queue, that callback gets executed in the call stack. Event loop will pick that callback from that queue, whichever queue it is, whichever queue, timers queue, check queue, poll queue, microtask queue, system special queue, any queue. The callback will be picked from there, placed in the call stack, executed in the call stack, and once the call stack becomes empty, only then the execution is transferred back to the event loop. This process, this moment when the execution is transferred back to the event loop, this is the next tick of the event loop. Next tick in the sense, now event loop is going to start again. Next tick of the event loop. Whenever this happens, first the system special queue is checked. This one. Next the promise queue is microtask queue is checked. Whenever every queue is checked, callback of, and if there is a callback, that callback is executed in the call stack, and that call stack after execution returns back to the call event loop. Then the microtask queue is checked, and then the timers queue is checked, and this happens after every callback execution. So I hope this is clear, this concept is clear, and yeah, this is pretty much like, people struggle a lot in this, and I've taken so many interviews till now, but I've always heard people saying macrotask queue and microtask queue, even though they know that I'm asking them Node.js specific question, but they even say they say macrotask queue and microtask queue, which is not correct. So yeah, that's all from my end. I hope you liked the video, and if you have liked the video, please do consider subscribing the channel, liking the video. Yeah, thank you so much. See you in the next video.